and again maximum at 615. Now, what are the important points when we look at two maximum and one minimum? So at this point dy by dx 0, then it should be on the line. This is f dash x 0 in here, and this is 6, this is minus 9 and 6. So in here also it is 0, in here also 0. In this point, again dy by dx is 0, it's a minimum. 0 and dy by dx. This is f dash x. What is this axis? F dash x equals 0. This is f dash equal maybe 5. So likewise. Now we have three major points we found out. Right, so we'll follow from here. We can identify few areas. Less than minus 90, 90 to 0, 0 to 6, and greater than 6. Okay, x value in x less than minus 90. What will happen if dash x? So this is 90, minus 90 less than. What you can tell about the gradient? Gradient is here positive. In this place also gradient positive. It means if x negative gradient, positive gradient above the x-axis, so then it has to be above the x-axis, above the x-axis. So then this is positive, so this has to be above. Then when x equal 9, what is it? Minimum. If it is maximum or minimum, cut x-axis. Yeah, it cut here, the point. Then in between here, minus 9 to 0. Minus 9x 0. From here to here you can see gradient is negative. So then it has to be negative. And it should end up with here. Then you should have kind of this kind of graph. If gradient is negative below the x-axis. Yeah, can you see it is below the x-axis, this part? Below x-axis. Then at x equals 0, again minimum. This is max, this is mini. So if it is mini, cut the x-axis. Yeah, it is on the dot. Cut x-axis. Now this distance 0 to 6, 0x 6. Positive again. If it is positive gradient above the x-axis, it has to be above x-axis. And in here, and at x equals 6, what will happen? X equals, it will cut x-axis, yes. And after that, from here to here you can see this is maximum, that's why it is cut, dy by dx 0 at maximum. And then from here to here it is negative, gradient negative. then it is below the x-axis. Uh, it means after 6 greater than x, negative gradient negative, then below the x-axis. So this is the gradient graph for this one. This is B. We'll discuss B now. Now you can see here from all the point, when you take this point, what is the gradient here? Don't think about that this is in the negative side because of gradient is negative. No, gradient is another concept. Now when you can see that this is a negative value, right? This, if you consider this point, let's say this is maybe minus 10, minus 7, right? Minus 10 this is, and this is minus 7. So because this is minus 7, so but don't assume that gradient is negative. Gradient is another concept. When you draw a gradient line, you can see this is positive. So hence, so gradient is up to here all positive. It means you can't see any, this side is blocked out because there are no negative gradient here. And yes, you can see gradient is high here. This gradient, high gradient you have, then this gradient level is getting lower. It means you have a high gradient here and gradient is getting lower and it goes to a 0. I know this is reaching to a 10, but we don't bother about it. We only check what? Gradient. So gradient is go closer to 0 when it's go to infinity. So this kind of curve. So if you look at x and f dash x, x is, which is going minus infinity to positive infinity. F dash x positive gradient. Positive gradient means above x-axis. This is part 7, part C, x equal minus 7 this. So now when you look at this gradient is negative. So it should be then below the x-axis. Then this is above and this is below. And horizontal, vertical asymptote. So as it is, so I can give a negative gradient like that. Then this is a point of inflection, 4, 3. It means x equal 4. This is 4. And here also x equal 4. If it is a point touches the x-axis. Now it can be touched from top or from below the line or above the line. Let's see how the curve goes. Now from here to here I can negative. It means the other curve is coming from below. It means it is touching this place is from below. And then again now it has a negative gradient. Negative, 0, and again negative. I can't go over. It's positive. So it has to be something like this. So this point is 4, 0. What is this 0 value? This is x dy by dx coordinate. When x equal 4, that gradient is 0 here because it's a point of enrichment. So you can write x and f dash x below x less than minus 7 negative gradient. If negative gradient below x-axis, and x equal minus 7 asymptote, and then minus 7 to 4, minus 7 from this place to 4, negative gradient below x-axis, and x equal 4. What is this one? Point of inflection. Point of inflection touches x-axis, and after 4, 4 greater than x greater than 4. So then again negative. Negative mean below x-axis. So that's how this graph works. This is D. So when you look at this graph, initially we want to find the minimum and maximum. So I can see max is here, mini is here. So then x equal minus 2. So it will crosses the this axis. So this is f dash x. So this is 0 also max. So the graph should go those through point minus 2, and this is 0, 6. Now, from left to minus 2, we can see that the graph is negative. The gradient is negative. Graph value is positive. Because of that, the gradient is not positive. Gradient is different concept. So the gradient is negative. In that case, it's going to be something like this. Now, from 0 to 6, sorry, minus 2 to 0. This again, this is positive. It means it is above the axis. And it has to end here. So in that case, we are expecting this. And then again, it has a negative. So then it is below the axis. And when it's come to here, the gradient is getting lower. So it's going to be like this. So let's discuss x and f dash x. Below minus 2, it has a negative gradient. It means below the x-axis. Below x-axis. Then at x equal minus 2, it is a minimum. So cut x-axis. And then minus 2x to 0, it has a positive gradient again. It's been above x axis. X equals 0 maximum. Then when it is maximum, what will happen? X equals 0 maximum, cut x-axis. That's why I put the circle here. And then greater than 0. Again it is positive. And this positive gradient. So positive gradient mean, sorry, negative gradient. Can you say it is negative gradient below x-axis? This is part A. Um, it has, when you consider this one, from here it has asymptote at x equals 6, and from here to here, all way that the gradient is positive. It means it should be above the x-axis. And from here to here, after 6, it is positive, and it should be above the x-axis. But what you can see, the gradient is positive, but the value is uh, when you draw a tangent line, you will see that the gradient is reducing. It means something like this. So x and f dash x, um, le- less than x, it is gradient is positive above x-axis, and x equals 6 is asymptote, horizontal, vertical asymptote, and after 6, x greater than 6, again positive. The gradient is positive. Don't think that it is in the negative below the x-axis and gradient negative. That is wrong concept. Um, Wrong thinking, because gradient is different concept. So you can see that gradient is positive, then this is 6 greater than x, above the x-axis. Um, Today, now section F. When you look at this graph, you can see that here the gradient, up to here the gradient is negative gradient. It means it should be below the x-axis. So it should be below the x-axis. Now, what you can tell about this gradient if you put tangent? So here you can see that tangent slope is very low. It means gradient is very low. And when it's come to here, it is very steep. It means gradient is increasing. And then it is reducing again up to here. So it is symmetric graph. So you will get this kind of graph. It's going to 0, 0, this curve. It doesn't mean that at this point there is no gradient. If you draw, you can see that there is a gradient, and with the negative value. So if you want, you can write in x and f dash x less than 0, negative gradient below x-axis, and x greater than 0, again negative gradient below x-axis. That's all basically. Now let's see whether you can see this right side. If it is a maximum minimum, it will cut. The point of inflection, touch. Maximum or minimum, cut. Point of inflection, touch. Maybe below, above, or below. A positive gradient, then above the x-axis. Negative gradient, below the x-axis. And vertical asymptote stay the same. Question number 2. We need to part A, sketch this graph. So when x equals 0, fx or y equal um, 16 will work out actually. 0 plus 1, 0 minus 4 square. So this is going to be 1 times 16, which is 16. So this is 0, 16. Now y or if x equals 0, x plus 1, x minus 4 square equals 0. It means x plus 1 equals 0, x minus 4 equals 0, or x minus 4 equals 0, x equal minus 1, or x equal 4, or x equal 4. So it is going to be minus 1, 0, and 4, 0. Now let's find the minimum and maximum. So if x equal x plus 1, this is x square minus 8x plus 16. When you simplify, you will get x cube 7x square plus 8x plus 7x square plus 8x plus 16. Okay, let's work out. We multiply by x everything. X cube minus 8x square plus 16x. Then multiply by 1. X square minus 8x plus 16. So this is x cube. This is minus 7x square plus 8x plus 16. Now let's take f dash x. This is going to be 3x square minus 14x plus 8. Now at stationary point, f dash x equal 0. It means 3x square minus 14x plus 8 equals 0. So you can bracket out this one. 3x minus 2, x minus 4 equal 0. So x equal 2 over 3 or x equal 4. So there are minimum, maximum or point of inflection. We can see when x equal 4, already we know y value, y equals 0, that's done. When x equal 2 over 3, what is the y value? So you have to substitute to here. Okay, if 2 over 3 equal 2 over 3 plus 1 times 2 over 3 minus 4 square. This is 500 over 27. Now let's find the double differentiation. If dash x this one, if double dash, if double prime is, this is 6x minus 14. Now at x equal 2 over 3, if double prime 2 over 3 is 6, 2 over 3 minus, so this is less than 0, so this is maximum. And at x equals 0, if double prime 0, that is 6 times 0 minus 14. So this is at x equal 4, not 0. 6 times 4, 24. 10 greater than 0, that is minimum. And we know that this graph x goes to positive, y goes to positive, and x goes to negative, y goes to negative. Now let's draw the graph. So it has minus 1 0, 1 point here, then 4 0, another point, 0 16 it will cut. Okay, and so 4 0, this is a minimum, and this one is 2 over 3, there is a maximum. So hopefully this is the maximum, and go to infinity, it goes to positive, positive to positive infinity, negative to negative infinity. Go this direction, go this direction. So then I can see the graph. So this value is minus 1 0, and this is 4 0, and that is also a minimum. Then this one 2 3, and 500 over 27. So now for gradient part B, we want to sketch this one for the gradient. So number line gradient is going to break from 2 to 2 over 3 and 4. So 3 section. So we will consider only minimum, maximum, and point inflection. Apart from that, the place where the gradient is changing. What are the places gradient is changing? At minimum, max, or point inflection. So those are the point should consider basically. Um, so and I can see this is 2 over 3, and then other 4 over 3. Now after 2 over 3, gradient is positive, so it will be somewhere here. After 2 to 3 to from this area 2 to 4, that gradient is negative. It means it should be in this back side. Then after 4, it is again positive. So then how do you draw this graph? So it has to be okay, this is gradient graph actually. When x equals 0, what will happen? This value 8. So it will cut 8 as well. This, so it's going to be something like this. This is 0, 8. This is x and f dash x. So this is x less than 2 over 3, positive gradient above x-axis. Then x equal 2 over 3, maximum, cut x-axis. Then 2 over 3 greater x greater 4, that is negative gradient below x-axis. Then x equal 4, minimum, cut x-axis. It is cut x-axis. And x greater than 4, again positive. It means above x-axis. This is x cubed 7 square plus 8x plus 16, and now f dash is this one. So this is when you simply break out, you can get 3x minus 2, x minus 4. We did this one. Now this is part C, and part D. This is f dash x equal 3x square minus 14x plus 8. Now from this graph we want to find what are the exact those values, this one, and this one. So origin axis, So we'll take this is y equal 3x square minus 14x plus 8. Now let's come out of this f dash x, we will put y. Then y equals 0, we can find those 2 points. 3 square minus 14x plus 8 equals 0, which is this one, 3x minus 2, x minus 4 equals 0, so x equal 2 over 3 and x equal 4. So 2 over 3 0 and 4 0, those 2 points. And x equals 0 from here, y equals 0 minus 0 plus 8. So this is 0, 8, this point. This is simple GCSE question. Gradient function cut x-axis as those 2 points and y-axis at this one.